Hello everyone and welcome to this session of our Digital V-Days. Today I can welcome Götz Schattmann with me. Hello and welcome.
Hi Markus. Yeah, I think it's the third time now in a row that I can attend this session. I'm very pleased to be here.
Yeah, you're right. Thank you very much. So, thank you for your attention today. And so my name is Markus Eberle and I will moderate this webinar today. Today we have the topic Smart Design with SMT Spacers. So, assembling electronic modules can be tricky, especially when you manual effort slows down the process. SMT Spacers offer a smart way to simplify and stabilize PCB assembly. So let's see how they can save time and costs. Götz, the stage is yours.
Thank you, Markus. Yeah, thanks for the introduction and hello and welcome out there. He spoiled a little bit about our topic today. However, to start into the topic, I have a little question for you. You don't have to answer live, but look at the question for yourself. So that's the point, yeah. I think everybody knows we're talking about a furniture supplier from Sweden, yeah, and they invented all these kind of kits, yeah. And everybody, I think, found himself in a situation where he needs maybe 3, 4, 5 hints to get the assembly of a shelf done. Well, what does that have to do with the PCB assembly? Well, it's kind of the same situation, but rather smaller. And it also can be really, really tiny and small, yeah? And then it becomes even more difficult. So, today, we're going to talk about SMT Spacers for assembling. We have a brief introduction, and I show you the different types of SMT Spacers we're offering right now. And then what's major interest for you is the design and processing, of course, some application examples, and also we have an economic comparison. And
wir können live starten gleich. Wir müssen noch einmal neu auf Start gehen. Ja, Slide 1, Markus vor. Da könnt ihr sagen, hier, sorry, wir hatten Technical Issues. Das ist völlig fein. Achtung,
also, gleich nochmal.
Okay.
Soll ich das sagen oder nicht?
Ja, ganz ruhig. Ganz gut.
Moment. Go on stage.
Klappe die zweite.
Mikro an. Markus,
Ist jetzt an.
richtig. Ja, oder vielleicht nochmal.
Ja? Okay.
Cool.
Okay.
Dann starte ich die Session. Jetzt kommt der Countdown. Und ihr seid dann direkt zu sehen und zu hören.
So, hello everyone and welcome to this session of our Digital V-Days. I'm very happy to have you all here in this session as we had some technical issues, but now hopefully all will run and all will work, and you can get all your information. As we have a tough schedule, maybe we can't make it to the Q&A session, but we will see. So let's just don't waste time and start into the session. My name is Markus Eberle and I will moderate this webinar today. And I have Götz Schattmann with me. Götz, nice to...
Hi, Markus. Yeah. So I just found out that this is the third year in a row that I am here to attend this session, and I'm very pleased to be here and welcome you all out there.
Yeah. Time goes on and time flies. So, the topic of today's webinar is Smart Design with SMT Spacers. Assembling electronic modules can be tricky, so especially when you manual effort slows down the process. So, SMT Spacers offer a smart way to simplify and stabilize PCB assembly. Let's see how they can save time and cost. Götz,
okay.
Stage is yours.
So, let's jump in, yeah. So Markus already spoiled, so anyhow we're going forward, and before we really enter into the topic, I have a little question for you. You don't have to answer right now here live, yeah, but you can ask yourself if you found yourself in such a situation. Exactly. So what does this have to do with screwing or assembling furniture? What does this have to do with the assembly of PCBs? Well, not exactly too much, but it's rather about the same, but the sizes is much more different normally, so much smaller. But even when it comes to smaller assembly, then this can be also tricky. And yeah, I think everybody found himself in a situation where he could rather need 3 or 4 or 5 hands to handle the current situation. So today we're going to talk about SMT Spacers, as you know from title. We have a brief introduction. Then I show you the different type of SMT spacers we have at current. And the major interest, I think, for most of you is the design and processing, what to take care about. We have some application examples, and we have an economic comparison against the standard technologies. So, history of spacers. Yeah, everybody knows spacers, like metal spacers, plastic spacers, or whatever. You can achieve almost every board-to-board height by combining different spacers. It's used in many ways for fastening components to PCB or the whole PCB into enclosure. And there's so many variations possible. And you can reach a really stable attachment. So it's very common technology and very common standard. However, is there any obstacles? So what we encounter is high manual effort that it takes, sometimes difficult handling. I mentioned about the 3 or 4 hands that you maybe need, and therefore it's time consuming. And if you switch for an example here, I have a PCB here, and if I want to screw in the PCB, the spacer, then I need one hand to hold the complete PCB and 2 hands, and I have to screw it all together, and you see how long this takes. So at the end, this is cutting down our flexibility and needs a second process. You need to have a workbench, you need to have your warehouse filled with the components. Procurement has to take care that everything is on your shelf when you need it. And that's, at the end, makes this solution costly. So this was our question: how can we achieve better handling with less manual effort, because this is what makes it expensive, and therefore reach more cost efficiency? And you might have guessed it, the solution. We're talking about the solderable SMT spacers. That means you can place this kind of components somewhere on your PCB and solder it together with other components. So it might look maybe like this example here. You can see the components here. Here's the spacers, and there's the bridge that goes on top, and here you have the fixation now. So about the general overview, the offering is a full automatic assembly. These parts come out of a tape and reel, and therefore can be very fast and precise processed and placed on the PCB by the machine. And therefore we gain a really high process reliability. At the end, we end up with high holding forces and high torques that we can achieve with a strong solder joint. And to fulfill your needs, we have such a large selection of types and shapes, like you can see here some examples on the right-hand side. And additionally, if you're missing out a certain length of a spacer, we can build them for you. Of course, we have to rely on the minimum order quantity. So here's a quick overview of the different types that we can offer. So this is the spacer with external thread. You can see the body, and on top there is an open thread, outside thread, and this component is placed on the ground PCB. You take a second PCB with a hole and put it through and put a washer and a nut on top, and your fixing is done. The pick and place machine can pick the component out of the tape and reel with this pick and place cap that is removed afterwards. Second one is done SMT spacer with internal thread. So you can see here in the cutted view, this spacer is also bonded to or soldered to the bottom PCB, and the second PCB is fixed on top with the screw just through it. However, this picture is not absolutely accurate, as there is a kind of shank that you can see here, and this goes into the PCB, into the bore hole of the PCB for 1.4 millimeters in the standard types. So the PCBs usually have a thickness of 1.55 to 1.6 millimeters. So this will end before the PCB ends, so the bottom side of the PCB is absolutely flat. Then next type is the SMT spacer with internal through hole. It's like the previous one, but not coming with a thread inside, but just with a bore hole, and you can lead a screw all through it. Now we have a very special type already. It's the reverse type, and here I can show you on the image. If we switch to the hand camera, so this point is to achieve a certain height to the bottom side. So if you look here, this type is assembled from top, but it creates a distance to the bottom. So what's the reason for that? It's very easy. If you have a PCB and you want to have the distance, the spacer on the bottom side, then you need to have at least two reflow processors. If you use this kind of reverse type, then you assemble this from the top, but you achieve the distance to the bottom. So you can save a full reflow processor, especially if you have a single-sided PCB, then this really saves you time. And it's perfect to have those for PCB stacks, for example, and you also get them with thread or with through hole as well. Next type is the right-angled spacer, and here you can see that we have two types. We have the block type, like this one, it's a bigger one, and then we have this one with the upright type with the positioning pins. Yeah? They have such a big surface that they create really strong holding forces. You can get them threaded or with a through hole, and what we can achieve here is a perfect 90-degree angled connection of PCBs. Yeah. So some more components for the assembling or making the life easier is this kind of SMT spacer with a snap rivet mounting. You can see it here in big. Showing it on the camera will not be very good visible. So therefore here on the camera, this small components here is the snap rivet, and you need a dedicated SMT spacer. You see here the bore hole is a little bit smaller than the general hole, and you just put those two components together and you push it in, and you will end up with a really, really strong connection. I have assembled here a sample for you, so you can see there is 4 of the components here, and yeah, I will not make it to break it up. Its extraction force is up to 76 Newton meters, and it looks pretty much like it's like a rivet. It's a fixed combination. However, you can use your fingernails and extract the pin as again, and then you can disassemble the connection again. Yeah. So for the next type, this is our mounting button. Looks pretty much or goes in the same direction. Maybe show it again here on the sample PCB. You see this kind of look. It's a little bit like a screw, but if you take it upside down, then it looks like a Christmas tree. And yeah, you can put it on top of all M3 threaded combinations or M3 threaded spaces, and then you just push it in and you create a very strong connection between those two as well. So holding force here is about 68 Newton meter in the average. Yeah? And the nice point is that you can easily unscrew it with a Phillips screwdriver. So here's some more. Then we also have some other components here, like a distance cap. It's made of plastic, and you can use it for all the 6mm types to gain electrical insulation, and it's exactly 0.5 millimeter height, so you can also reach the intermediate height if you're missing that in the row of the different heights. Next one is a plastic screw, especially when you need the electrical insulation. They're available in M3 and also in 2 different flammability classes. So now it comes to design and processing. That's some points that we should take into consideration. Here we see the spacer with the external thread and the full bottom surface. This is the solder surface. This is rather big, and together with the solder joint and solder meniscus, we receive a really good retention and torque. You see on the right hand side the footprint. Of course, footprint is a little bit bigger, like 7.4 millimeters, while the body has only a diameter of 6 millimeters. And you see the center pin here. This is used for accurate positioning, and therefore, of course, we need a bore hole here in the footprint. Yeah? And very important, non-plated through hole is required here. So I mentioned already that the solder meniscus is so important for high retention and torques. Yeah? This all around on a 360 degree, a full meniscus, this will guarantee that we gain really high retention. Stencil size is given with 150 microns, and here we have the stencil suggestion. And of course, you optionally get those components also without a center pin. Why this? Imagine you have a PCB where you can't use bore holes, like IMS PCB with a metal substrate, which is used commonly for LED boards, for cooling effects. with a solder connection through the borehole, this would lead to a nice shortcut. So next thing is about the SMT spacer with the internal thread. Body diameter is the same, it's all the same material for the M3 types. Of course, the smaller types have different outer diameters. Yeah? There's a drill hole required, again, for the shank here. We call this a shank or a tap. Yeah? And this goes into that borehole. And here is the surface, the pattern surface is again where the solder joint is being placed. So this shank, I mentioned it in the beginning, goes into the PCB while your PCB remains flat on the bottom. And here we receive all around, we receive high retention with the good meniscus all around. Therefore, the non-plated through hole is important, and I'm going to tell you why. Stencil is also given in a suggestion for 150 microns, and here's what it looks like. Optional, we also have types with bottom closed, means the borehole is not getting all through, but we have this kind of shank which is closed on the bottom, and there is a closed borehole with a thread inside as well. So why non-plated through hole for SMT spacers? The potential problems that could occur is that tin could draw into the thread. You see here from an internal view that the solder is raised up here into the thread. Now imagine you want to screw in a screw and the thread is almost closed because there is tin inside. On the other hand, the solder paste that goes inside here is lacking on the top surface, and therefore we end up with a reduced retention of the SMT spacer. So next problem about is that the SMT spacer might move out of the center of the borehole. Of course, the borehole needs to be a little bit bigger than the component itself, so the pick and place machine can easily place the component on the right place. Normally it's at least 1/10 of a millimeter bigger. And what happens, or what could happen, is depending on the solder type and so on, when it goes to the reflow oven in the SMT process, the tin gets liquid on one side of the borehole earlier than on the other side. Depends on the direction. If you have the heat on the one side, then of course it gets liquid here. And the component is always drawn to the side where the solder gets liquid. And in that case, here a gap could appear. And with a gap, the problem is that solder could drop down. Again, missing solder would lower as the retention force. You can also see it here. While this one is drawn here, the other one is drawn to this side, and there are different effects that can be the source for this problem. So misalignment is a big problem, especially if you have more than just one spacer on your PCB. Imagine you have 4 or even more, and you need to hit all the holes on your top PCB. Maybe through the tolerance it runs out of the tolerance and you can't screw some screws in. And therefore a non-plated hole is originally recommended. So how did we prove or give proof for that? Of course, we did massive qualification testing, and we have full report of all the different types of SMT spacers that we have, showing us the minimum and maximum forces and the average, and yeah, you see shear force, pull force, extraction force, and so on. Yeah? So you can ask to receive the test report. Just ask your local FIA or ADM. They will be frank to give it to you. So to show this in detail, you can see here the different scales, and on the left-hand side you see the plated through hole. If you think normally you think it could be a good idea to have a plated through hole, just to have a better connection. But we proved that this is not necessarily the case, and you can see that the variations of the lines here is so vast. Yeah? And the major point is, if you look on the scale, maybe it's hard to see about the numbers, but this number is exactly here. So if we really want to compare this, then we end up here. This makes it obvious that non-plated through hole is perfect or ideal. So when it came to qualification, of course, we had a test for the upside down soldering. Of course, all the components here, all the spacers have been soldered regularly on top, yeah? And then we flipped the PCB to see what happens if the solder melts again, if they just fall off. And I can assure you nothing fell off. We even made it harder, and we put screws and washers to the spacers, and they even didn't fall off, and now they're qualified for a 5-time reflow test. So for perfect alignment, if it comes to the right angle type, you see here there's this sort of chamfer, and the bottom surface is this one, yeah? So it's lined on the side. So this is the component from the side view, and we're talking about this little gap here. So why this? What we want to achieve is an exact 90-degree positioning here. Yeah? But if we do a traditional component without this sort of chamfer here, then the meniscus and the forces will draw the component slightly away from the edge of the PCB. And we will not end up with a 90-degree angle. Yeah? Therefore, this chamfer was taken in place, and therefore we achieve real perfect angles. Then again, for the right angle type here on top, you see the stencil recommendation and the footprint recommendation. So the pattern fields is where the solder comes on, but we need those channels here as a path for all the activators and flux, which is contained in the solder paste. This is about 50%. Inside the solder paste is flux and activators, and they disappear during the refill process, and they need a path and a way how they can go out, yeah, to avoid having lunkers and voids inside these surfaces, which would again reduce the retention force. Yeah? So on the bottom side here, no solder paste in drill holes. Very clear, you can use the solder paste in drill holes. Therefore, you can see here the stencil design. This one is all covered by the stencil, which is made of stainless steel. So these bridges here hold again the surface, and during the solder printing, you see here again the PCB, and there is the stencil with the opening, and only the opened areas can be soldered. Now this area should not be, there should not be any solder inside of the borehole. Therefore, we need to cover this, and this is done by this. Just as an explanation for the mask. Yeah. Also, what you can do if the surface is not big enough for your calculation of the solder paste, you can overprint on the solder resist, and during the refill process, the solder paste will be drawn into the right direction or position. So here we have an example. On the left-hand side, we placed some of the right angle types, they did not sit very accurate on its position, and this was after soldering. So by the capillary effects, they drawn themselves in the right centered position. I also have a nice video about this, if you're interested. So positioning, it's important to have an accurate positioning after soldering. Therefore, we should take care about the non-plated through-hold and minimize the floating effects. Now, what is a floating effect? A floating effect can happen if you have large components very close to the SMT spacers. You have thermal shadows, so the component is not heating up perfectly, and therefore it can be drawn out of the position. What also happens is that there can be large ground planes which draw away the heat and therefore draw away the component a little bit. So what you can do is adjust the solder profile, change the solder paste. Maybe you have a chance to test with a different solder paste. Then change the soldering direction. Maybe it makes a difference if you run it this way, or if you just turn 90 degree or even 180 degree, and then you might get a different effect. You can also change the stencil design. You can narrow it a little bit, then it cannot move so far. Especially you can increase distance to big components, and therefore you reach better heating of the component, and adjust the opening of the solder resist as well. And you can minimize the solder pad. There's a lot of possibilities that you can use. I've been talking about the thermal centering effects. If you have a big ground plane, then this might draw it out of the position. There's a solution called thermal relief, and it's normally you find this function in your EDA tools. So for this pad, you have a thermal relief here, so this one is decoupled from the ground plane. So the components come in a tape and reel with polyimide type, so it can be easily drawn out of the tape, and the component or the pick and place machine will place it on the right position. The tape and reel components come with a Kapton foil on top, and sometimes they have this little flap to remove it afterwards. But this flap is important, not the flap, but the Kapton is important to draw the component out with a vacuum pipette out of the tape and reel. So we have different variations, like you can see here. We have the R-type with a flap, we have the RR type without the flap, and the RX type, where you need a special nozzle here, which is then creating a vacuum against the surface. So, and we also have a patented one, which is called perforated foil. You see this breaking point. You don't have to remove it. You can just use a screw and screw in, and it works. So this is the variations that we have as an example. So then you can use them in a standard solder profile. You don't need to adjust your typical solder profile too much, yeah? And yeah, you will end up with good results here. So can all be processed together with other SMT components. Yeah? ROS and REACH compliant. Yes, these components are ROS and REACH, otherwise we couldn't sell them to the market. Zero lead is already in preparation. Beginning of next year, we will switch all the equipment that we have on stock to the zero lead versions. So here we still have some application examples. I showed you the sample board. Ask your local representative, yeah, to spare you one of these sample boards so you can play around with it. Here to have some more ideas, yeah, just supporting other connectors. And here with the right angle types as well, with a special solution with the USB-C, where they come with these fixing screws as well, and then it looks like this, and you can fix the cable on the PCB. Some height limitations. Yeah, if the maximum height is 16 millimeters, if this is not enough for you, then you can use two of the spacers, one on top, one on the bottom, and you reach 32 millimeters. Yeah? But always take care that you don't take two with a thread. One should be unthreaded, one should be threaded, so you can easily screw it together. Also, this is traditional when you use the standard spacer studs, yeah, that you screw it from underneath of the PCB, but you can also use SMT spacers and just screw this one on top. The advantage is that the PCB is very flat on the bottom side underneath, and the position is very accurate of the SMT spacer, and it's much easier in the handling of the assembly. SMT spacer and power? No. These SMT spacers are not designed for electrical purposes, as you can read here. Of course, they are made of steel, but steel is not a good conductor, and therefore we also have our high power terminals, and if you want to lead the current over it, so this is just not specified. Everything else is up to you. So how can we take influence on the perfect solder joint? So here's a little diagram, yeah, what all has to be taken into account. So here's some bad pictures about too much tin or too little, where we have voids in the solder paste, yeah. And of course, you have to take care about the best solution. Yeah? Here's some more about the pad geometry if you want to have a better fixing, because the first thing that breaks if you want to break off such a spacer is the pad, and the pad can be fixed with internal holes and vias. So this is like bolts keeping the pad on the PCB. And I promise there will be an economic comparison, very speedy. We go over it, SMT spacers via standard spacers here. And we see that assembly, the price, this is I think rather 2 years old, something like this. The price is much higher than for the standard spacer. This is clear. And the assembly costs are even higher by hours. Yeah? So you have to teach the machine where to place it and everything. Yeah? And then it comes to the real assembly process. Yeah? And if you then count together how long it takes to manually screw together a spacer to a PCB, it takes 0.8 with the SMT spacer, and in total 30 seconds. And that's where we very fast reach the break even, which makes the SMT spacer even more interesting. Yeah? yeah, also it's just a part on your bill of material. So your procurement doesn't have to buy the studs. So it's just a component on the BOM, and your EMS provider will buy them for you, just like all the other components. Yeah? And yeah, therefore we have the high savings by automated assembly, and yeah, it's fast and time saving. We have so many variations and combinations possible. It's almost like a Lego solution. Yeah? It's really sometimes fun to create good solutions here. It's absolutely solution-oriented, and it also lowering the thermal stress for the SMT components if you only have one time the reflow process. So here's the conclusion. Again, fully automatic assembly, very precise, very fast, very good process, very clear process like all the other components, strong holding forces, and yeah, so many variations in length and sizes. Yeah? And at the end, it's much faster to assembly. Yeah? Okay, so this is the end. For now, if you have any questions, I don't know if you still have time for questions.
So first of all, Götz, thank you very much for your presentation.
Sorry, I had to run through it a little bit faster. Yeah,
yeah, we are very sorry for that. But now we take the time and let's have a look. You can download now the handout. Hopefully this will work. If not, you will also get an email from us with all information afterwards. And then let's check the question here. So I think one question we can do, and this is from Paul. With these being soldered components and typically single-sided for something like the right angle device, what are the connection strengths actually like? As I can see that if these were used in a high vibration scenario, they would just fit the solder pads from any PCB due to the vibrations and leverage. Also, what are they like under impact, as some of my users aren't exactly gentle and they bash the equipment around a fair.
Okay, yeah, of course we've seen especially that scenarios many times, and also of course they have a limitation about the holding force. However, the limitation is always how hard your PCB is holding, or how hard the solder pad is holding to the PCB, because this point is the weakest point. Yeah, so I've showed some possibilities how to increase this. You can also increase the size of the solder pad, and this will of course increase the total force as well. If you're asking about the value, we can send this to you by this special report, because we have very clearly tested this, and I don't have it in mind exactly. Usually I count it down by crates of beer, so the standard right angle type will hold at least 2 crates of beer. Maybe this helps.
Okay, good. Then thank you very much. Yeah, so then we are already at the end of our sessions. I know there are some questions left in the chat. We will answer them, or Götz, I think you will answer them later on by email. And yeah, if you have any other questions, then just email us. So stay tuned with the Digital V-Days, and you should also now see a link and you can just register. Also for example, the next session with Götz this afternoon, rethinking power connectors, how WE Redfit crimp saves time and money. So stay tuned. Thank you for your attention and have a nice day.
Thank you. Bye.